Types that directly store their values are called value types. Value type variables are stored in the stack. The stack is a pool of memory that the .NET Framework runtime allocates for variables and method parameters that are value types. These variables and parameters are declared in code, so the runtime allocates the proper amount of memory for them. It's a fixed size, fixed amount of memory. Value types make efficient use of memory because the runtime has already allocated space for them on the stack. Because value type variables hold their actual value, they must have a value associated with them. The .NET Framework assigns a default value to a value type variable if you don't assign one at the time you declare the variable. The default value for all numeric data types is 0, and the default value for the Boolean data type is false. But reference types, on the other hand, don't store their values directly. Instead, the variable stores the address of a memory location where the value of the variable is stored. So a variable declared as a string or object stores a reference to its value, not the value itself. Reference types are stored in the heap, which is another pool of memory. But rather than allocating a fixed memory size for the value of a variable, the heap location is dynamic. This is because the compiler does not know how much memory the runtime is going to require for a string. It doesn't know how long that string is going to be. It might be 1 character, it might be 2 gigabytes of characters, all within the range of a string. And it also doesn't know how much memory is going to be required for an object variable because it doesn't know what kind of object you're going to store in that variable. So both strings and objects can be of almost any size, unlike an int or a double, which are a fixed size in memory. Now, when code assigns a value to a string or object variable, the .NET Framework runtime finds space on the heap for the value and then stores in the variable a reference to the location on the heap where the actual value is stored. Every time code accesses the variable, the CLR has to grab the memory location from the value of the variable, then go to that memory location to grab the actual variable value. This involves more work than simply grabbing the value of a value type. So reference types are less efficient than value types, and that's a very important difference between the two. Now, if you've worked with other programming languages that use pointers, a reference type really is essentially a pointer. Not exactly, but close enough. For the most part, though, you won't have to work directly with pointers. C# does include features where you can if you really need to, but most of the time you don't need to worry about them. And the reason is that CLR hides most of the messiness of pointers from you, managing them for you, very efficiently in fact. But you still need to understand value and reference types because the type you're working with in code affects how you have to write efficient code. And one thing to note is that classes are reference types. So the .NET Framework contains thousands of classes, including string and object, but many, many others. And you can create classes yourself. So in your code, you'll likely work with many different kinds of both value and reference types. Remember that an object variable can store information of any type, whether it's a string, integer, date, or any other type, classes from the .NET Framework and so forth, your own custom classes included. So in this code here, I'm declaring an object variable, an int number1, and I'm initializing number1 to 77, and then I'm setting the value of object1 to number1. This is a value type because it's an integer, and I have literal integer values stored there. This is a reference type because it's storing a reference to this other value. All right, and then the code displays the value. But what's important here is this interaction right here. When object1 is set equal to the value of number1, the .NET Framework copies that value to the heap and returns a reference to the value. And this is called boxing the value type. All right, so again, value type, this is stored, This 77 value is stored directly in this variable in the memory allocation. This is a reference type, so it has to actually store a reference. And then, but that means that because this is a value type, this has to be copied to the heap. This is stored in the stack, this is copied to the heap, and then this contains a reference to that value out in the heap. So then, when this line of code displays the value of object 1, which will be 77, it'll just display that value, the .NET Framework uses the reference to copy the value back into a value type, in this case a string that it needs for the console.writeLine method. And this is called unboxing. Or sometimes really the full unboxing the boxed value type. So you'll sometimes see a reference like that. Now, boxing and unboxing occur anytime code converts a reference type to a value type and vice versa. So I have some more code here that converts the object variable to a string. So now I have declaring a string, string1. Keep in mind that this is a reference type as well. And I'm going to take number 1, execute the toString method, and store that value in string1. And this is another example of boxing, because you're taking a value type, converting it to a string, and storing it in a reference type. Now, another thing about boxing and unboxing is that when you unbox a boxed value type, you have to use the same type. So for example, this code here, I'm going to uncomment it. What it does is I'm converting this value to a short. This line of code is going to generate a runtime error because object 1 is boxed to an int type and is being unboxed to a short type. Now the problem isn't that this statement can't handle short types. C# will do an implicit conversion if it gets a valid short, but it can't perform this conversion. So now when I run this code, I'll select E for value and reference types. We'll get the 77 that you saw briefly there, but then we get this exception. And it says that the specified cast is not valid. And in fact, this happens so often that there's an explicit exception for it, system.invalidCastException. And the problem here is that a short is not an int, so the common language runtime complains about the operation.